Hey everyone, here we are. We're in the third set of videos I'm going to create for the RTEM Hackathon. This time I'm going to focus in time series data, which is the sensor data that you're going to be extracting from the Onboard API to really answer a lot of cool questions, hopefully. So here you can see the sort of cover page for the Kaggle data set or Kaggle data page for the RTEM Hackathon, which we've been looking at for the last couple sections. We had part one where I talked about the API, what is an API, how to use it, how to use the Onboard API wrapper. You have part two, which we talked about point list. We downloaded point lists from the backend, the Onboard backend, and kind of explored them, looked and kind of see what type of data that we have. And now part three, we're going to look at actual sensor data from these points. We're going to process those data and play around with them, and I'll show you some really great pandas functions that will be very, very helpful for you in this process. So if you were to click on this part three, what you'll end up with is going to this sort of notebook. You can create a Kaggle account, which allows you to then copy and edit this notebook. You can see 10 people have already done this. And I've already done this in my own account. I basically have created this version, or I'm going to edit this version. And of course, the first thing we need to do in this is load the Onboard client API library. We need to load the pandas library as well as the RTEM client. Here we go through the process of connecting to the client using our API key. So of course you're going to have your own API key, as you remember from part one. You can either copy and paste that in here, or you can use the secrets part of Kaggle Notebooks, which I've used, and I have the hackathon key there, which I'm using. So once we've logged into the RTEM client, now I want to take the metadata list that we got from part two. So this is something that's pretty common that I like to do. It's not something you always have to do, but sometimes I take snapshots of data from the API that I then save as CSV files. If you remember, we did that last time. And I load those CSV files. I load those snapshots, as opposed to going through the whole process of querying the API and merging things and doing all kinds of things. So creating these like bookmarks of data or snapshots of data, which is really easy in this competition because the data is not constantly updating. So it's easy for us to do that. So we're gonna load the metadata file. This is the file that contains. Whoops, we gotta load that file right there. There's 44,000 rows in that file. Okay, there we go. We got the file loaded. I executed the lines of code out of order. Here we have the file loaded. We have 24 columns here in this file. Each of the columns has most of the columns have all the data in them. We can look at the first 5 rows by using the .head function, which shows us that we have building IDs, we have a timestamp for when it's last and first updated, a location, point name, description, tags, equipment name, all the different information you might want to use to query the database, the Onboard API, for further data. So we have a lot of points here. We have 44,262 points. Let's go ahead and figure out a way that we can query through this metadata list to find some points that we want to use to query the time series. So in this case, let's look at zone temperature sensors. So this is essentially the thermostat reading. In a zone, you have a thermostat. It's got a temperature sensor inside, which it's reading, and it's sending that information back to the VMS to be able to control that space. So that for zone temperature, that point type is 77. So if you need help, looking through and understanding how to figure that type of information out, you can use the Onboard API documentation. And we use this in previous notebooks. And we want to look at, let's say, zone temperature sensors for fan coil units, right? Okay, so let's go ahead and extract that. We're going to have now 341 points out of the 44,000 points. 341 of them are fan coil units with their zone temperature sensors from fan coil units. So let's go ahead and take a little stab at querying larger amounts of time series data. So here we're going to load some libraries that are going to be helpful for us. Date time is a library PyTZ, which is a Python library related to time zones. And we're going to import specifically several onboard API functions that are going to help us here. So let's get a list of the points. We can get the data related to the points. Well, actually, sorry, we're looking at the zone temperature sensors for fan coil units. We want to get the time range, the date time period that we have available to us. So we're going to get we're going to take the column first updated and last updated, and we're going to convert those into timestamps that are human readable. If you remember, we have these are originally in the system as Unix timestamps, which we need to convert using this chunks of code here that you can see here. And we are going to create two variables, start and end, which are going to help us query the database according to the range of data that we found in the metadata list for these type of points. So we use the function called time series query. We have the points that we want to query. We have a start time and end time. And so if we do that query, we create the query, we execute the results here. And because we're querying hundreds of points for a certain time range, it takes a few seconds, or it could take longer depending on how much data that you're collecting. And that data set here we can see is 19,000 rows of data with the timestamp, and the column heading is the point ID of that particular point. So we took this snapshot. It's relatively hefty chunk of data. Let's say maybe we don't want to query that again from the API. We want to, kind of store that in a CSV. We can do that using toCSV as a function, which we'll store as a time series. So that we've downloaded a chunk of data. In the next video, we'll look at a really useful function called resampling.